Hey guys, episode 5 here again. Good to see you again. So today we're going to be talking about increasing and decreasing functions. Now, when you first hear increasing and decreasing functions, you would first think that it's actually pretty easy to determine just by looking at the function. Oh, hey, it's increasing here or it's increasing there. But how do you actually really explain that? And let's explain it right now. What does it mean to be an increasing function? So let's say I gave you this graph here, right? This is y and this is my function f of x, right? And if I were to have given you, let's see, this is x, this is y, and the graph looks something like this. It increases here, it shoots down here, and shoots back up, going over here just a little bit there. So now, let's say the beginning point is capital A, the second point is capital B, the third point is capital C, and the last one's capital D. Now, these points at the bottom, they're called intervals. These little intervals determine whether something's increasing or decreasing, but it's just labels. You know, on the number line, it goes from left to right, 1, 2, 3, 4, 5. You know, for here, I'm just saying that in general, I could have any points on the intervals here. Now, what's interesting is, let's say if I pick another point here and here, right? This would be count as the function f of x1, and this is f of x2 from this point here. But as I go down, there's this little point x1 and x2 here on that same interval. So what we see is, again, the graph increases from this capital A to capital B, and then it decreases from capital B to capital C, and then it increases again from capital C to capital D. So let's write it out. The function f is said to be increasing on the interval square bracket a and b. So before I continue, square bracket means that it's including the point A and everything in between to point B inclusive. Decreasing on inclusive B and C on the interval, and increasing again on the interval C and D. So ideally what I'm trying to explain here is that in general, when you're showing this visually, it makes sense why you go by certain intervals, and they're on each intervals, depending on which interval you pick of your value, that'll affect your function, and it'll determine whether or not your function will increase and decrease. So let's write that out in general, what that means. If x1 and x2 are any two numbers between A and B, with x1 being strictly less than x2, then it makes sense that the function f of x1 and f of x1 should be less than f of x2. Now, that's not always true, but that's why we have these two additional properties here. A function f is called increasing on an interval on an interval I if f of x1 is strictly less than f of x2 whenever x1 is strictly less than x2 in I. So what this says is that no matter what, depending on my function, as long as it satisfies the condition that if x1 is always going to be less than x2, most of the time, not all the time, but most of the time, the function f of x1 should be less than f of x2. However, this is true for all the cases here. Now, the other situation, how do I write this out decreasing? Well, let's see. In similar fashion, it's the same way where let's see, let's put a little line here, where it says a function f is called decreasing on an interval I if the function f of x1 is greater than f of x2 whenever x1 is still less than x2 in I. Now, this part kind of confused me at first when I was reading this. This was confusing because I didn't understand how come I see the function f of x here is less than f of x2 and x1 is less than x2. This part makes sense because if this is small here, then it makes sense that the function of it should be small. But this is the part I didn't understand. How come my function f of x here, f of x1, is greater than f of x2, but even though my point x1 is less than x2? That's the part I didn't understand at first when I was first reading this. However, it makes sense because you can't have a point of x1 that's bigger than the other point. If that makes sense. Because it's kind of like saying, this is how I like to think of it as. You have a point here, right? If it's going to be less than the other point on the number line, it's always going to be increasing in this way. Now, if I have a point that's bigger, well, if a function starts off bigger than the other point, it's going to go down like this. Does that make any sense? So let's give a good example of what I'm talking about. A physical example of mathematics. But that's why I had to talk about this because I felt a little confused at that point. So this was a good review about that topic of what's increasing and what's decreasing. So let's give a live example. One of my favorite ones is the example we'll be using is y is equal to x squared. So again, visually, it looks like this. Here's your x-axis, your y-axis, your 0, and it goes down and shoots up. So that's my function here. So we can agree that y equals x squared is on, y equals x squared is decreasing on the interval negative infinity to 0. When I say negative infinity, I'm talking about this left side here. So as we're going down, all these points here, it's going all the way down to 0, including, that's why we put the bracket. And increasing on the interval, I'll just erase this side. On the interval square bracket 0, comma, positive infinity. always remember you have to put an open bracket for any infinity that you use because of how infinity is a notation. It constantly is growing. So we just made this symbol just so we can have a value for infinity, but in reality, the symbol just represents that it's continuously growing. So you can't like include something that keeps moving. Think of it that way. If something keeps moving and you try to catch it, but it keeps moving, you really can't include it in something. That's why this has to always stay, the bracket has to be open, not closed. Closed is just the point that's there and it doesn't move at all. So it's like, oh, we can include this point. So it makes sense why we're allowed to write it this way, that infinity has to be open and any other number has to be included with the square bracket, depending on the function. In this particular function, every single number works perfectly fine. So it's always dependent on the function whether or not every single point works. So anyway, so that's the lesson. Well, that's the review, excuse me. That's the review. So I want to thank you guys for watching Absolute 5. Be sure to follow me down below of my social medias. And I will see you guys tomorrow. Well, yeah, definitely tomorrow just tomorrow. So I want to thank you guys for watching Absolute 5. I'm Roger Palomino, and math is infinite.